All right, let's get started. I had these three beads up there and I asked you to look at one. Which one do you think water could go through the fastest? Now, for the record, these are supposed to be representing pieces of like sediment or soil. So we've got small pieces, medium pieces, and large pieces. And they're not supposed to be contained in a beaker. So I'm imagining that there's no beaker because obviously water is going to get stuck in the beaker. So if this was just the ground and the water was able to freely flow through them, let's go with smallest being 1, medium 2, biggest 3. Which one do you guys think the water can go through the fastest? Okay, good to know what you guys think. Now, my second question was, which one has the most hole space? Which one did you pick? Most hole spaces. All right, I'm seeing a variety of different answers. Some of you saying 1, some of you saying 3. We'll come back to that. Let's go over your homework. Are you ready for question number 1? We've got causes a lowering of the water table. Which one will cause? First off, we're lowering the water table. It means it's getting deeper in the ground. Do we have to add water or remove water to make the water table go deeper underground? You got to remove water. So the water table in this one is labeled as right here. If we want that to go lower, we would need to remove water. And which two processes are removing water? A and B are the ones removing water. A, the water is evaporating. B, it's doing transpiration. So for the record, C is rain, that'll add water. So any that had C were not the answer. B and D, well, D's up in the clouds, not adding or removing water. So it's not going to really affect the water table. What is not represented? There are 2 of them from the water cycle. So they have to be things from the water cycle that we did on the front page. Which one of these 6 words are missing from this? What'd you pick? Show of fingers, please. I'm seeing a couple different answers. So for the record, those of you holding 4 up, you got it. There is no runoff and there is no infiltration in this one. I did see evaporation and melting. I think I saw some people holding up 2. Remember, melting is not even on the water cycle. So that can't be it. And evaporation is there. It's letter A. For this one, transpiration and condensation. Transpiration's B. D is condensation, so that one's not it. And precipitation and freezing, again, freezing was not on the water cycle, and precipitation was C. Most water vapor enters the atmosphere by, which one did you pick for this? Okay, seeing a couple different answers. Again, it is answer 2, evaporation and transpiration. Precipitation is actually how the water leaves the atmosphere. It goes from up in the sky to down on the ground. So that's why number 3 was not the answer. How many of you skipped the reading? Oh, okay, quite a few of you guys. If this was a test, don't do that. We didn't skip the graph. Okay, so that'll at least help. One thing that would be important, so letter A represents the time when approximately 50% of the precipitation from the storm has fallen. B represents the time when the peak runoff from the storm is flowing into the stream. The delay is the difference between A and B. So we notice a couple different things here. So first, if you did read this was before urbanization. I guess you had to make sure you knew what urbanization meant. What does it mean? Making it more city-like. By the way, when you make a place more city-like, what are some things you might change? What happens to the land? One thing is it gets cleared, and what gets put on top of it instead? Building concrete, whether it's building roads, parking lots, etc. So we would take our open fields that we have surrounding our school and put buildings and parking lots and streets there instead. So we're taking open space and turning it into, can you come a different time? I didn't do it. What was your original grade? So you're not trying? Thanks, Ethan. All right, so by putting concrete instead of open fields, what can you expect? So this isn't even a question, this is just kind of teaching while going over homework. Water can't soak in as good in cities. So cities will have more runoff than infiltration. So the delay in time from A and B on both graphs is due mainly, so this, remember, is when it rains to when the peak runoff was. So they're saying both of them have a delay. Why is that? What did you gather from this question? Please show me on your fingers. You all did your homework, so you all should have your fingers up. All right, I'm seeing a couple different answers. Guys, when it rains, does that water immediately get to a stream? No, what's it got to do? It does have to, it takes some time to get there. That is why the answer is number 2. The precipitation, it takes time for that precipitation to move to the stream. Number 5, how did urbanization affect the delay time between A and B and the maximum? So let's take this from the beginning. Did the delay time decrease or increase? Would it decrease? Look, we went from this long time to a much shorter time. So it did decrease. It's not 3 and it's not 4. And did the maximum here increase or decrease? Increase. Process of elimination, that's answer 2. Got to be able to read these charts. So you really needed 0 knowledge to answer either one of those questions. In general, the probability of flooding decreases when there is an increase in, show me what you thought first, 1, 2, 3, or 4. All right, I think I'm C, yes. There'll be less flooding if there's more infiltration. So less flooding with more soaking in. So you can see the importance of knowing the definitions for the vocab words. All right, this one, which process should be shown in place of the question mark to complete the flow chart? We have precipitation. It goes to runoff. It gets to the ocean. It does something to become water vapor. What is that missing spot? That is evaporation. You guys are mostly correct. It evaporates up into water vapor from the ocean. 2 left. A container is placed in an open outdoor area and the evaporation rate can be observed. The water will most likely evaporate fastest when the weather is. Which one did you pick, please? Okay, I'm seeing a few different answers. So first, let's go with, should it be warm or cool to make the water evaporate fastest? Warm. So not 1, not 3. Should it be humid or dry? Should be dry. And by the way, does windy make sense? Yep. That was water evaporates faster when it's warm out, when there's dry air, when it's windy, and when the water is spread out. And finally, during a dry summer day, the flow of most large New York streams generally do what? Which one did you pick first? Let's go through this. You might not know this one. Okay, that's exactly what I thought. Now I want to see everybody's answers because everybody did the homework. Okay. So first of all, which one can we get rid of? You guys have lived here long enough. Large streams in New York, generally, one of them's wrong because we live here. Which one do you know is true, not true about rivers in New York State? 4. They do not stop completely. They never stop completely. During a dry summer, Sean, you had up, which is another one we could get rid of? 2. Why is 2 definitely wrong? Yeah, so, right, so if it's dry, we're not going to have rivers increase due to more runoff. If it's dry, they're not going to get more water somehow. So will it continue because some groundwater seeps into the stream, or it will remain unchanged due to transpiration from grasses, shrubs, and trees? Which one you think is true for those? Oh boy, it is number one. Guys, think of Cattaraugus Creek over by Tim Hortons in the dead of summer when it hasn't rained very much. Okay, you should notice, or those streams in your backyard, they do continue moving. They don't stop, but they don't have as much water. And they're certainly not going to remain unchanged, especially guys, what does transpiration do? Where's the water go with transpiration? Into the air. Will that cause the rivers to be unchanged if the oh my gosh, if the water's going into the air? No. So this was, to answer that question, I would have had to look at all four answers and see which one made the most sense. And again, it's not from necessarily this class that some of you love so very much. It is just because you've lived, you should know that they don't stop, they don't increase. And I guess then you could have gotten down to the 50-50 answers there. How'd we do? 9 questions, approximately 11 points each. Minus what? -2, so 22 points off. You got 78. It's decent. Not supposed to get 100 on these, but yeah. Sure, I'll give you one bonus point. Just want you to think about, okay, how would you have done? Is there something, for those of you who missed a whole bunch, was there something that kind of blew your mind? All right, let's keep going then. So we are here on page, I don't know what page this is, 5. And we're going with factors that affect infiltration. By the way, what do I mean by infiltration? Soaking in. If you did not know that off the top of your head, put in parentheses, soaking in. And then, so we're going to put a factor over here. And over here is the permeability rate is greatest when the following characteristics are true. So we're going to be talking about some things that are going to change in the soil, and then what change will allow the water to go through the fastest. So we're specifically talking about soil. Can you think of some things that might affect how fast water goes through the soil? How loose the soil is. We talked about this one yesterday. So if it's nice and loosely packed, like most of the playground, the water will go through nice and fast. But underneath the slide, underneath the swings, we always have those puddles because water doesn't go through as fast. Can you think of anything else? That's 1 out of our 4 we need. What do you mean? Oh, dry, yes, if the soil is already filled up with water, like those days when it's been raining for a long time and it just keeps raining, if it's already filled up, there's no room for more. So whether it's dry or wet, we'll control how fast the water goes through. That's 2 out of the 4. I actually think those were 2 of the harder ones. Right, can you think of something else? Let's everybody else think of some here. There was one I had to investigate a minute ago. What, Pam? The size is the second, or is the third one. We looked at these guys. The size of the particles will affect how fast the water goes through. Most of you guys, I think, which one did you guys say? 1 being the smallest, 3 being the largest? Yeah, most of you said 3, okay? There's one more thing, and I honestly am not sure if you're gonna get this one. No, I don't think we put it in our notes yet. That's not what I'm asking. I'm asking what will affect the infiltration. So 3 things that we can control that will change how fast the water goes in. Well, we or the world, I guess. Can you think of it? That's part of it. You got it. All right, let's go through these. All right, you ready for the official answers? Oh, maybe not, because I'm not ready. Oh, sorry to keep you up, guys. I feel the same way. Oops, lost it. All right, permeability. These are the 4 factors. Oh. All right, the 4 factors we're going to start with. So A is going to be shape. 3 is going to be size. 4 is going to be sorting. Sorry. A is going to be shape. B is going to be size. C is going to be sorting. And D is going to be packing. What shape particles do you think, round or angular, will water be able to flow through faster? Round. So we've got angular, if you notice here, they fit together nicely. The round doesn't fit together good. Creating a pathway. I like to think of this pathway as hallways. Permeability means there's nice big hallways for the water to go through. Just like we got big hallways in schools usually. We got nice big hallways. The bigger those big hallways allow for good flow. So for permeability, the rounder particles will allow water to go through faster. So next to shape, the rounder the particle, the faster the flow. Now we already did size with these ones up here. What do you think for size? Which one will allow the water to flow through the fastest? The larger. So going back to those hallways, there's still hallways here in the small ones, but those hallways are really small. You'd have to go through those hallways single file. Unlike, it kind of reminds me of a fire drill. When we have a fire drill, how is the flow of traffic in the hallway? Pretty decent, right? When does the traffic slow down for a fire drill? When you're at the doors. Why do we have to slow down to go through the doors? Right. There's only 2 doors. You can only fit 1 person through each door at a time. Whereas in the hallway, if we have to, we can go like 3, 4, 5 kids across the hallway. So we're easier to go through those bigger hallways than we can go through the smaller. You'll still get out with the small ones, but it'll just take some more time. So for size, the larger particles. What do I mean by sorting? What's sorted versus unsorted if we think of different kinds of parts? Could be by size, could be by shape. But if we, for example, these are all sorted. They're all about the same size. They're all about the same shape. Here's unsorted. Which one is water going to be able to go through faster? Sorted. What's up here? Stuff filling in the gaps. It would be like if I threw a bunch of desks and chairs in the hallway. You still get through, but can you go through as fast? No, you got to go around and find a path through. Or you could jump through, but jumping is still going to take more time. But you're not wrong. You could jump, but it still will slow you down. So sorting, we got the sorted particles allow water to go through faster. And the last one, like we already talked about, we got nice loosely packed sediments. Then we take those same sediments and pack them together tighter. Which one can water go through faster? The unpacked or loosely packed. That's how fast water can go through. Now, the next question is factors that affect runoff. So when is runoff going to increase? First of all, if runoff is happening a lot, what's not happening? Okay, so factors that affect runoff. So again, this is not soaking in. So if we're not soaking in, it's running off. Yeah, can you think of some? The same, very similar, yes. All right, so let's start. Whoa, I guess I'm just gonna go through it. Let's talk about let's talk about your actual backyard or an actual street or an actual field. When do we have runoff so the water doesn't soak in? That's one. When the ground's already filled up. If the ground's filled up, no more soaking in. It's another one. Yeah. What do you mean the shape of the ground? Okay, so yes, so that's true as well. What else about the shape of the land? Can you think of one? Okay. No, you're not wrong. Okay. But we want it to run off. Guys, have you ever seen a flood? Okay, Cam, wake up. When do we have flooding? When it rains. How like it's raining right now, or are we flooding? Why not? The water's soaking in, so when will it flood? Okay, so what might happen? What might cause water to not soak in? Too much rain. There's times when it rains so fast that the water can't soak in. Here are some more. So when the ground is already saturated, Sean said that one. What you guys missed, which is where I thought TJ was going, is if it's a steep slope, the water can't sit there long enough. If the ground is frozen, we could allow water to not soak in. Or the weather, if it rains so fast, the soil can't take it in. Or if we're on pavement instead of nice permeable substances. All right. Couple more concepts. I take it back, not just one. So let's see. Now we're moving on to porosity. How is porosity different than permeability? You did. You wrote it down yesterday. So if you don't remember, go back and look. What is the difference between porosity and permeability? Thank you, though. I want more people thinking. It's the amount of hole space. So I had asked you to look at some hole space. Now, if you look at the answers here, or at your, let's just do it this way. All right. Factors that affect pore space. The first thing we're going to look at is shape. So if you guys could add that, just like I have it there in your notes, we're going to be looking at shape. We got round and flat. I think I showed, nope. Round and flat, which one's going to have more hole space? Round. Round particles have more hole space. Flat particles, those holes get squished and they cannot hold very much water. Next one, what do you notice the difference between those ones? What's supposed to be the difference here? We got these groups. Yep, so how tightly packed. And hopefully you see if they're loosely packed, those holes, there's nice big holes. Lots of room for storing water. If they're squished in tight, no room for water. And last one on this page, we got sorted or unsorted. And the sorted ones, they got all that room in between. The mixed up ones have smaller pieces that fill in between the larger pieces. And now for the finale. Are you ready? Back to these guys. Hole space. Porosity. Which one did you guys say has the most hole space? 1, 2, or 3? 3, 1. Anybody want to say 2? All right, so we'll take 2 out of the way. Which one has more hole space? 3. A lot of people convinced it's 3. Who wants to defend their answer? Kenna? I see big old holes. Look at the size of that hole. Look at these holes. Those are some big holes. Who wants to defend its number 1? Just because you're not making eye contact with me doesn't mean I don't remember what your answers were, guys. Who wants to defend number 1? Somebody's going to have to. Couple of you had number 1 up. Sophia, what are you thinking? Look at all those holes, everybody. Gazillions of holes in number 1. But they're tiny holes. Now we're going to look at 3. Look at those big old holes. But guys, how many holes are there in number 3? Fewer. Yeah. Wait, let's add back in number 2. Guys, what size are those holes? Medium-sized holes. And how many holes are there? More than this one, but less than that one. Anybody want to change their answers yet? No? Not a single one of you wants to change your answer. Huh? Dakota, you changed it to 1, 2, or 3 has more hole space. You guys are really being this stubborn? None of you think I'm trying to trick you? None of them. They all have the same amount of hole space. How could that be? Oh, not because they're all in the same beaker. I knew what you meant, but no. In total, there's the same amount of space. Exactly what both of you guys who defended the answers said. Sophia's right. Look at all those holes. Teeny tiny, or really a huge amount of holes. But like everybody said, they're small. So a bunch of small holes. Then we looked at 3 and we looked at these huge holes. But there's not many holes. Guys, it's kind of like when we go on a vacation. My family of 4, should we bring 1 ginormous suitcase or 4 small suitcases? Okay, it's probably more convenient to bring 4 small suitcases, but that's not the point. 4 small suitcases can add up to 1 large suitcase. In the end, all 3 of these have the same amount of holes, space, same amount of holes, space. So lots of tiny holes, a few really big holes. So what conclusion can we draw from this? Okay, you could say it that way, or you could say, guys, who's ready for it? Size does not matter when talking about porosity. Here's the last bit of notes. Larger particles, yes, they have large holes, but not as many holes. Small particles have smaller holes, but a lot more. So in the end, size does not matter when talking about porosity. I can guarantee you they're going to try and mess with you on this one because porosity and permeability have very different answers and the words sound similar. You do need to get them straight in your head. Yes, the water will go through the bigger ones faster, but in the end, they can both hold the same amount of water. Remember that anybody who wants to do test corrections. You have until Tuesday next week, yeah. Maybe. One of them things. In our house, we refer to one of them things as going for a WALK, because we can't say that word out loud in front of our mouths. No, I don't have, are you trying? No. Then yes, I guess you can. Did you need that back?